Hello, everyone. My name is Ian Curtis. I lead the solutions architecture team covering both the West and Central for Zscaler. And in this session, I want to cover with you a few topics. The first one is the NIST Zero Trust Framework. Now, I know you've probably been inundated with all things zero trust from every vendor, software vendor, cloud service provider, hardware vendor, services provider, and so on, as well as possibly even read the official documentation. So what I want to do is level set on what the official documentation says very briefly, just to make sure we're all on the same page. Also, I think with the explosion of zero trust centric documentation out there, there's probably more misinformation out there than there is actual useful, tangible, applicable data that we can all leverage. And then I want to talk about the CISA Zero Trust Maturity Model. And the reason that is so relevant, because the vast majority of organizations who started on the zero trust journey have not actually gotten to that optimal state. So what we're going to do is leverage the maturity model to show us how to get from point A to point B in a way that's relatively easy, that doesn't have to take a whole lot of time. Now at Zscaler, we've been able to help customers accelerate the adoption of a zero trust strategy. And not because zero trust is a product per se. It's not something we're simply trying to sell you. It's a strategy. But with Zscaler at the center of that strategy, we've demonstrated that we can work with the other critical vendors in your ecosystem to help get you to that optimal state much, much faster than what's called out in the official documentation. Now, if you haven't read all the official documentation, I don't blame you at all. It can be incredibly long. In fact, I pasted there on the right of the screen a document I came across when I was in the US Army several years ago. This document is 26 pages long, and it tells you how to bake a brownie, the proper way to bake a brownie. Now, I'll eat probably thousands of brownies in my life. I'll never read this document. And this just, to me, shines a light on the ability of public organizations, regulatory bodies, government organizations to create documentation that is just arduous. And what it's ultimately trying to call out might be relatively simple. So we'll cover those things. I want to give you some clear steps to adoption as well. And then finally, I want to give you an overview of how to evaluate cost properly. These things will all be covered at a relatively high level, but we can follow up after this and get much more granular into either specific stories where we've been successful, or the technical details, or the costing conversation as well. So let's begin. Before we dive in, I want to tell you a very quick story. So a couple of years ago, one of our customers sent the vast majority of the employees to work from home. And they were not able to replicate that security stack that they had invested in their data center, in their headquarters, all the way out to everybody's home, of course, right? So what did they do? They turned on a VPN. Now, the VPN, as we all know, can be hacked relatively easily, so they enabled multi-factor authentication. In this particular case, the attacker was able to bypass MFA on one of those remote users. Now, how they did this, we don't exactly know, whether they were able to actually bypass MFA or they just called them pretending to be IT and got their username, password, and temporary token or something like that. But nonetheless, they got in, right? When they got in, they didn't have access to anything particularly interesting. So they hung out for a while. They had a relatively short dwell time before, lo and behold, a system administrator, of all people, sent their password over the wire in clear text. So you might say to yourself, who sends their password over the wire in clear text? This can't be a normal thing, of course, but it is a normal thing. I found out that the most commonly violated security policy last year was passwords being sent over the wire in clear text. 70% of policy violations were passwords sent over the wire in clear text. So nonetheless, this attacker was able now to access almost everything. The system administrator had way too much access. And so they're hanging out in the environment, and they're not very good at covering their tracks. So what they do ends up being discovered. Something raised an alarm in the SOC, and however they responded, it spooked the attacker, and the attacker left. But the attack didn't end there. They now have credentials into the environment that allowed them to persist into the environment. So they sold those creds on the deep web on a Russian chat forum. And now in steps a state-sponsored Russian threat actor. These guys are a lot more savvy. They have the law on their side, probably. They're oftentimes well-funded. And most importantly, they know how to cover their tracks. So they hung out for about 30 days. They're hanging out for 30 days, which if you follow APTs isn't a whole lot of time. But they planted 2 back doors during that time. And the SOC actually discovered those back doors and they shut them down. So they had one backdoor as their primary and then one as a backup in case it was discovered. By the time they shut down the backdoor, it was too late. They had already stolen tons and tons of protected health information out of AWS. Now, this protected health information, if you don't already know, is extremely valuable. I can steal a credit card and it's worth almost nothing. But if I steal someone's health record, I can make a fraudulent claim against that record to make tons of money. So these attackers were able to monetize this in multiple different ways. You might call it a double extortion, possibly triple extortion attack, but whatever it was the second most costly breach that was made public last year to the tune of about $700 million. This was Medibank. Medibank is a healthcare payer organization based out of Australia. In terms of how they operate, you could think of them as a relatively traditional financial institution with a financial product that happens to be applicable in healthcare. So they have to be HIPAA compliant. Now, why did I go through this attack? The primary reason I did so was because the attack itself is actually not that interesting. If you follow maybe MITRE, maybe you follow the kill chain or some other framework that allows you to look at what the attackers are doing nowadays, you'll notice that they tend to follow a relatively predictable process. They have to do some recon. They have to make entry into the environment. They're going to drop a payload likely at some point, move laterally, try to cover their tracks. And at some point, they have to monetize what they've done if they're monetarily motivated. So this would be double extortion, triple extortion, ransomware, selling records, you name it. And so Medibank had all the traditional defenses. By industry standards, they were doing and are still doing everything right. We talked about how they can't replicate the security stack they invested in at everyone's home. Well, of course not. But these location-centric defenses have proved to be inefficient. They assume trust. So they interrogate with MFA. They make you validate in multiple different ways, but once validated, assuming there's no malware on the device has been patched, they plug in their username, password, and token. Well, now we assume on a continuous basis that you are who you say you are, and we let you have access to everything within that domain. And because the industry who produced tons and tons of firewalls, these network devices that are supposed to stop all the bad stuff, they failed to do their job initially. So they said, well, how do we segregate east-west traffic? Oh, I got it. More firewalls. And so these east-west firewalls required that everybody re-IP their entire environment. Ask anybody how they've done in that process. Are they actually firewalling between every workload and container and user? Absolutely not. So it's not really proved out to do its job effectively. Also, we find that they were making decisions based on technology. Why do I buy IDS, intrusion detection systems? Well, because it's a thing and everybody has it and everybody says we need it. So it's a technology-based decision that doesn't really consider outcomes and why we're buying it. Also, my visibility tools, they're so critical to how I operate my security and how effectively I stop attackers in their tracks. They were all siloed. Every little piece of technology had its own single pane of glass, or as I call a single glass of pane. And we forked all the logs to the SIM, who was supposed to solve the visibility problem. That thing ended up producing tons of false positives. So we end up tuning it down to the point that now it's like not as much false positives, but are we missing stuff? It's really hard to tell. And the simple fact is, this has not worked. I mean, we're spending more on cybersecurity than we ever have, but we're taking giant leaps backwards. This approach just simply isn't working. And that is why NIST released the Zero Trust Framework to begin with. And the primary theme that you'll notice is that we need more context. If my kid walked into my house today and said, Dad, can I go to the movies? I would ask a few questions. I wouldn't just say, wait a second, are you actually my kid? They say, yes. Well, have you ever been to the movie theater? And we say, yes. Okay, you can go to the movies. Disregard the fact that it's 2 o'clock in the morning. The movie theater they're trying to go to is 2 states away. That the van in the driveway doesn't have any windows on it and they're trying to take my daughter to the movies. That's an obvious no answer. But in this old world, we only considered a couple variables before we gave a yes or no answer. Also, we should be location independent. It shouldn't matter where that user is connecting in from or from what. We should have a similar experience across the board. Once they're in, we don't assume trust. We don't say, hey, you're in now. We continuously interrogate that connection. And every connection to every app is treated separately. Okay. Also, least privilege is not on a per domain basis. It's on a per connection basis, on a per app connection basis. And ideally, would provide no network access at all. That user connecting in, is it possible to connect them to an application without letting them see the IP address of that application? Or what other networks or IP address that application has access to thereafter? It absolutely is possible. Also, we make decisions based on the outcomes we're trying to achieve. So we kind of start fresh and we say, this is our overall strategy. What fits into that strategy? As opposed to, hey, they put AI, ML on their technology. We should probably buy that. That's not good decision making, of course. Visibility has to be org-wide, end to end. When we talk about automation, we talk about things like the automated development of policy that will allow or deny access based on new information that was received in real time. Policy development no longer being a manual process. And all of these things, this org-wide visibility, automated policy development, allows us to now adhere to governance standards as per the security policy in a much more expedited fashion. So the Zero Trust maturity model. First of all, we talked about the difference between a traditional model and the Zero Trust concepts. Well, how do we get started? First, in order to adhere to this, it says we should look at our environment through these 5 pillars. I have my identity, I have my devices, networks, apps, and data. From there, I consider applying visibility and analytics across all of them in a continuous basis. No snapshots, no point-in-time stuff. Then, once I can see across them all, I should be able to automate and orchestrate. We're talking about dynamic policy development, identity, informing devices, informing networks and applications, and so forth, dynamically developing policy in real time. And then this should all allow me to apply governance as per the security policy. So at the bottom of all of these pillars, we have our traditional approach. This is the traditional stuff, location dependent, unaware of context way of doing things, right? But then as we mature toward our Zero Trust model, we get to this optimal state at the top. Now, the maturity model says we can adopt all of these things independently. So I could start with my networks and move to identity, but eventually I'm going to have to consider them in tandem, especially as I apply visibility, analytics, automation, and orchestration across them. And the final thing I want to pull in from the documentation is that this is not a publication that's developed by federal organizations for federal organizations. This is something that is applicable for every organization, regardless of vertical, in the United States to help develop the posture of our entire economy, really. Okay, so where do we begin? First of all, we have to do our gap analysis. Look at each one of these pillars. What areas do we have covered? If I look at the actual maturity model paperwork, it provides me with a whole bunch of frameworks, templates that will call out specific technologies and capabilities I should have for each one. So I interrogate those a little bit and I figure out what I have covered and what I don't. Then I want to figure out where I can have the greatest impact for the least amount of cost. Oftentimes you'll find you can have a pretty great impact without doing a whole lot of implementation of an arduous project, if you will. But once I identify the areas I want to start first, I then ask a few questions. First of all, do I have the systems, resources, infrastructure, personnel, and processes to take on this project effectively? In other words, do I have systems that are like dependent on IP pass-through or something that would stop us from adopting a newer approach? Do I have the ability to have a rollback plan? Do I have the people who actually know how to do it the new way, or do I actually have a skills gap? So once I consider those things, I can get started. But now, there's a few key concepts that we've seen help customers adopt Zero Trust much faster. Remember that most organizations have not gotten to that optimal state. But we can say that the third parties who say things like Zero Trust is a multi-year journey, well, we've done it much, much faster for many companies. And so we can, maybe after this session, if you have more interest in following up, we can talk about some of those stories and how they've been successful. Some key things that we've learned, though. First of all, bias toward action. We talked about the explosion of documentation out there. Everybody wants to put their name on a Zero Trust framework if they can and sell it in that way. There's no shortage of official documentation as well. You can get stuck in analysis paralysis very easily. You have to begin. You have to figure out where you're going to get started and take on this project. Also, earning executive support, maybe you are an executive. But what we found is that getting dollars allocated for a project like this is not simply about having lots of data. A lot of us come from engineering backgrounds, and we're very good at interrogating data, making sure we have quality data, and telling the story of that data. But what we found also is that it helps to take off the engineering hat for just a second and put on the politician hat and tell a story. You don't have to leave the politician hat on for very long, but enough to find an anecdote that's useful. So look at a peer organization. Is there a competitor? Is there somebody in your vertical who operates similarly to you who has been attacked? Well, what defenses did they have in place? What losses did they incur, right? And how do they change going forward? These types of stories we found can help earn executive support just as fast as good data. Ideally, you still have good data. I'm not saying you shouldn't have industry-wide data like loss expectancy and rate of occurrence and that kind of thing. We talked about considering both cost and impact. So you want to buy down risk. You want to find those quick wins. If you invest in something, get a win early. Focus on doing that and then slowly climbing the mountain so that you're not trying to wait until the end of the project to realize any value from this journey. And finally, like I said, everybody's slapping that zero trust sticker on their box that they've been selling since the 1980s. Know the difference between those vendors who are helping you get to those real zero trust principles and those vendors who are just kind of repackaging something old and trying to reframe it as zero trust. All right, so I said with Zscaler at the center of your zero trust initiative that we can have the opportunity to accelerate the adoption of these principles. What I mean by that is that with the Zero Trust Exchange, our Zero Trust Exchange is not going to provide you all the things you've ever needed to be full zero trust, but we believe it sits at the center of that platform. So I'll explain. We have over 150 data centers that span the globe. At these data centers, we have the ability to apply the vast majority of intelligence you need, the ability to bring in the intelligence from those third-party vendors that you're likely already working with on your devices and identity providers and so forth to make informed decisions about how to defend your environment based on business policies that you define. So step one is just getting connected into the platform. I want to make this as simple as possible. I don't need everything encrypted to the highest standard because while I support those encryption standards, really all I'm focused on is getting them onto the platform. I don't want any of the intelligence living on the devices or the workload or the IoT devices. I just want to get them onto the platform as quickly as possible. So things like a lightweight client or a GRE tunnel will usually suffice. Then I want to consider that additional context. So we as Zscaler can look at devices and look at users and consider much more context than just, are you authenticated? But we can say, where are you connecting in from? Is this a new device we haven't seen before? What is your device posture? Also, maybe you're using an EDR vendor like a CrowdStrike or something. We ingest their score as well and consider that alongside what we're looking at. We look at, are they authenticated through your existing identity provider? And with all of this additional context, we can better inform the next step, which is controlling risk. So are they sending data outbound that shouldn't go outbound? We don't need to look and read all your data to see if there's a partial hash match for something that's going outbound. Maybe they're sending a social security number. Maybe they're sending credit card information. Maybe an attacker is trying to extricate data from their attack, like the one we saw earlier. We can match or partially match data and control risk thereafter. For inbound traffic, are they downloading malware? Is it a partial match for malware, or does it behave like malware where we should run it in a sandbox? All of the risk and mitigation features that you would expect with something like a UTM function are applied simultaneously to the traffic. That's very different than how many organizations do it today. That means that when a packet traverses our environment, instead of saying, okay, firewalling, then malware, then IDS, IPS, then DLP. Instead, what we can do is apply all of those rule sets. We call it single scan multi-action. With a single scan, we can apply all those features at once because we run it all in a single memory space. This makes us run much, much faster. So between the fact that we have far more data centers than we would typically need and the way we actually decrypt and apply policy, end user experience is usually much, much better on a platform like this as compared to, say, hairpinning over a VPN to a data center on a firewall. This actually typically takes its most natural traffic path. So then we need to enforce policy. Okay, we know who's connecting in. We know there's nothing anomalous related to the connection. There's nothing inside the connection that would be malicious. And now we can allow or block like a typical service. But we could also say, now, wait a second, your posture score on your device has dropped just a little bit. You didn't do your patch last night. Well, Mr. or Mrs. CEO, we're going to let you continue to do business, but there's some critical applications we're going to isolate away from you until you do that patch on your device, right? So we can isolate some things when the risk is not elevated too high. We could prioritize some traffic. And if we're certain that this is an attacker that's connecting in, we can actually proactively deceive them. So if you've heard of deception technologies, that's phenomenal. That's automatically integrated in this platform. That means it's entirely separated from production. There's no risk there. And you can sit back and just wait for this to happen. And then when an attacker starts attacking this environment and going after these vulnerabilities, you can become much better informed about how these attackers are targeting you. Maybe what you thought was your most critical asset, the attackers actually care about something else. Maybe you find out, oh, they like to move laterally using RDP. Maybe we should consider locking down RDP in the future just to be safe. Okay, now this is a critical step here. We initiate a separate connection to the distant application. If it's on the public internet, it's an outbound connection. The reason this is an important part of the process is because with a proxy-based platform, as opposed to a routed platform, the attacker is unable to fingerprint the devices that you've connected into the platform. That means it's a new IP address. They can't start doing their reconnaissance to say, well, who am I talking to and what vulnerabilities do they have? They can't even see that device. The only thing they see is the Zscaler IP addresses in the Zscaler platform. For those users that are on your platform, who are maybe actually working with you, we have a separate outbound connection initiated from your data center and your cloud apps to the Zscaler platform. This means that the users who are that are supposed to work for you cannot now fingerprint the IP addresses of all those applications they're connecting to. They're never on the network. They can't see the IP addresses. Once they're interacting with an application, not only do they not see that IP address, they're unable to start scanning around and seeing what else they're connected to. Now, on the internet, if they're connected out to, say, a website that we're not certain it's malicious, but we would prefer not to just automatically trust it, we can do things like browser isolation. So we can actually spin up a browser in our cloud, in one of our data centers that your user happens to be connecting to, and stream the bits back to the user. So the web page is actually running in our cloud as opposed to on the user's device. So that way, if there is something nefarious about that website, we don't have to worry about it now running on the end user's device and them getting malware. The results of this have been huge. The fact that the attackers cannot fingerprint the user's device on this platform, they can't do reconnaissance. We can browser isolate in our cloud and these kind of things. We've had organizations go from an average of 300 malware infected machines and wipes they had to do in a given month down to 0 or 3. So that's hugely impactful to improving productivity and reducing true positives for attacks, right? Now, the final piece is we have to apply end-to-end visibility. This is that final piece that allows for the visibility, the automation, and application of governance principles. This is per user, per device, per hop, per app, performance analysis. If I'm concerned, a user calls in and say, hey, this application's not working very well, I can quickly log in and see every hop along the way, the application itself, the device, their Wi-Fi, the user, and say, oh, your Wi-Fi is slow. Or I can say, oh, there's a router in the route somewhere that's not performant, right? So the mean time to innocence is much, much faster, and it eliminates a lot of the finger pointing, and that improves operations dramatically. Now, how does this compare to a traditional environment? Well, first of all, in a traditional environment, a user is expected to validate their identity before connecting into the network, a network security device that gives them access to the full network. This identity is often treated in isolation from the things that are actually checking the device posture. And identity and device posture fail to inform that network device on anything that may not be, less than stellar, if you will. So then my applications and workloads have separate security tools, right? But the user, once authenticated and brought into the network, they have full network access now. I can see the IP address of the application I'm connected to, and I can see everything else that is connected to. And so the data then becomes accessible. If it's within the same security domain, data extrication becomes much easier. Because all of these things have their own single pane of glass, and visibility, automation, and orchestration across these platforms becomes incredibly challenging. The simple fact is that you cannot do zero trust. You cannot apply the very specific principles defined in the Zero Trust Framework documentation using legacy firewalls and VPNs. It's just not possible. And so I talked about the fact that Zero Trust is not simply a product, right? It's a strategy. I'm proposing that Zscaler be at the center of that strategy. However, I will say that your identity management, someone like an Okta, for example, needs to be able to integrate with this platform automatically. We do that very easily. It can be just a few minutes of logging in and adding a service provider to your platform. Endpoint security management. We trust that, the CrowdStrikes and the Windows Defenders, and these folks have done a great job in many years of identifying attackers' techniques and procedures, as well as different types of malware. So we ingest their APIs and vice versa, and it allows us to take that information and apply that to the additional context we apply for our customers. Every SD-WAN vendor out there consumes our APIs. So a remote office with an SD-WAN vendor, no problem. They can automatically connect into the platform. And those SOC analysts, the folks who operate in Splunk every day, well, we don't want to change how they operate on a daily basis. So they can continue to operate in their SIM. We can get them the logs. It's as simple as saying, do you want all the logs or you just want the most critical logs? And we'll get them access. And finally, your applications, be it API scanning for CASB and SSPM and SaaS environments, or CNAP in the public cloud providers, or even your private data center with SAP and VMware. We consume these things so that we can have a holistic strategy. Now, how do we actually consume these things? How do we actually go from point A to point B? Who's going to be involved in this project? How much time is it going to take? Well, we can go much further down this rabbit hole, but I want to give you a quick example of how fast this could possibly be and how we've done it for a customer who has about 15,000 users. We've also have much bigger customers with more than 50,000 users, but this is just kind of a middle of the road example. So step one is we need to get those users connected in, those offices connected in. This is your branches and end users. We need network, security, and your desktop folks. If we can do that, it's about an 8-hour project. It doesn't have to take too much time. Next, we want to get applications connected in. So security needs to be involved, typically, maybe your Active Directory folks. This is about a 13-hour project because we want to not only install that cloud connector in your data center and cloud environments, but we want to do some application discovery and identification of what the applications are in those environments and segment them off properly. Next, creating policy. This is the most time you'll spend on the project, right? So we want access and identity. We want those risk policies that we described: allow, deny, isolate, prioritize, deceive, and so forth. And we estimate about 20 hours for 15,000 users. Next, the rest of the ecosystem. We want to get your SD-WAN providers connected in. We want to get your SIM, your SOAR, your identity provider. This is a very fast process, probably the most fastest in the entire project. And finally, you have to have that end-to-end visibility. Your SIM manager may want to be involved in this, your security architect, and probably several other personas inside your environment would be interested to have access to this tool so they can see, users, devices, hops, and applications, and every connection between them. So now, to tie off on this presentation, what does the maturity model documentation say about cost? Something interesting that it goes over toward the end of the documentation is the fact that to establish an entirely new security strategy for an organization is going to require some upfront cost. But the whole purpose of doing this is not only to be more effective, but so that future allocations can be done so in a more prudent way. So over time, it should actually be much cheaper to take on a zero trust framework. Ideally, we get out of this world where we're just constantly throwing money at the problem and getting less for each dollar we spend. So it does say that, number one, allows for more prudent allocations of funds down the road, but also it should improve productivity. I talked about the Security Operations Center having to wipe less machines. Well, that's a lot of time given back to the SOC so they can focus on better things. Less time with incident response. Also, there's a merger and acquisition use case called out here where we say, okay, well, if I'm really not providing full network access, then I'm not concerned about things like IP overlap when I acquire a new company. Now I don't have to replicate everything to their environment. I can just say, hey, you guys have to install this client. It's a lightweight client. It's going to get you connected into the Zscaler Exchange, the Zscaler Zero Trust Exchange. And once in, I just decide which applications I want to give them access to. And so, Bram, they're on board now, and anything I want to do thereafter, I can take my time doing because I've now given them application access and not had to worry about overlap of network and security resources. The end user experience becomes much better. I can SSL encrypt and decrypt at scale, apply policy at scale, and allow the traffic to take its natural path as opposed to hairpinning through a data center or through a cloud provider or security service somewhere. And I can just apply policy and get it to the application they're connecting to much, much faster. And finally, because I'm not directly advertising any user's IP addresses or device IDs out to the web, the attack surface is reduced extremely, so dramatically, which actually connects back to the fact that we're doing less machine wipes and incident response as well. So if you want to dive more into some of these concepts, I'll ask you to follow up with whatever resource you know from Zscaler. You can reach out to us directly and we can go over a few things with you. We can talk about the technical details of each one of these things I addressed, or we can tell you some stories about some other customers who've been successful on this journey. We'd love to have you talk to customers as well. So I hope this has been useful for you. I thank you for your time if you had the opportunity to watch it, and I look forward to hopefully meeting each one of you someday soon. Thank you.